Hi guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. And yes, I Rakesh Sir once again welcome you all to the digital electronic concept classes, and we have been trying to conquer and understand the concepts of latches and flip-flop. We started with the very fundamental of the latches, that is the SR latch, then the JK latch, D latch, T latch. Then we also started first with unclocked latch and then we moved towards clocked latch. The clocking used initially was level triggered clocking. Then we understood the problem, that is a race around condition. We understood what is the problems with the level triggered circuits, and then we moved towards the edge triggered circuit, that is the flip flops. And after that we have been talking about some questions of flip flop, conversion of one flip flop to another, what is the state diagram of flip flop. Okay, so for a particular flip flop, now we know the characteristic table, now we know the state diagram, graphical symbol, characteristic equation, everything, right? And now let's take some question that can be based on a similar concept. Flip flop, understanding of flip flop will be required, but the question will be little bit timing and waveform based, timing and waveform analysis question. So let us get started with the session, guys, quickly. Right, in case somebody new to the session, this is a brief intro about me. This is your mentor and educator Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from the Indian Institute of Science, Bangalore. Trained more than 50,000 students in my more than 11 years of training experience. I commonly deal with the subjects of control systems, signal and system, digital electronics, EMT in the technical domain, and I deal with the aptitude and maths in the general, that is the non-tech domain. Yes, good evening all, keep joining the class. Right, the Hall of Fame, as I told you, several students of BYJU'S Exam Prep outside in the GATE 22 examination with All India rank 1, 2, 3 and many students securing AIR under 100, right? Okay, Nitish, so you just need to look what went wrong for you and how good was your preparation, what subjects you didn't study and what next you are planning. Okay guys, so this is the question number 1. So let's take the questions and the analysis of the questions. In the circuit shown, choose the correct timing diagram of the output Y from the given waveforms. W1, W2, W3, W4. So there are the 4 given waveforms in the options. Right, that is W1, W2, W3, W4. This is the clock applied, and now you are able to see we have 2D flip-flops. Now in this 2D flip-flops, okay, we have the clock. Both the flip-flops are what type of triggered? Negative edge triggered. Both the flip-flops are negative edge triggered flip-flops. Negative edge triggered flip-flop, as we have seen the symbols earlier. So negative edge triggered flip-flops, everyone is able to recall. The negative edge triggered flip-flop will respond to negative edge of the clock. What is the negative edge? An edge going from 1 to 0. A transition from 1 to 0 is the negative edge. A transition from 1 to 0 is the negative edge, right? ठीक है जी. So both the flip-flops are a D flip-flop and negative edge triggered, and then whatever is the output of D flip-flops, both the D flip-flops is ANDed to obtain the final output Y. Right, what is the output Y out of the given waveforms W1, 2, 3, 4? Yes, come on everybody, let's start looking into this. Now we know that, everybody, we very clearly know that what is the output? What is the output of the D flip-flop? So the output of the D flip-flop Q plus is equal to D, and what is connected to this one is X1. What is the output of the next flip-flop? The output of any D flip-flop, the next state of any D flip-flop is given as Q plus equal to the D and Q plus equal to D, and that is equal to how much? That is equal to the X2. X1, X2, both the waveforms are given, but output will only occur. The next state will only arise when you have a negative edge of the clock, right? So let's have a little zoomed diagram here, and let me first highlight the negative edges of the clock, right? What we need to highlight here, guys? Negative edge. This is the next negative edge. This is the next negative edge. This is the next negative edge. Next negative edge. Right. Okay. Now everybody try to see. Let me name them also. No issues. Right. Let this Q1 plus and this is Q2 plus. Okay, but the Q1 plus is directly equal to X1. The next state of Q2 is equal to the X2. So when the first clock edge is coming, everybody, when the first clock edge is coming, what is X1 and X2? Let me just read down these values here. This is 0 and this is 0, right? So what is the next state of both the flip-flop is 0, and 0 into 0 will be 0. 0 into 0 will be equal to 0. So at the first clock edge, at the first negative clock edge, the output should be 0. We are trying to find out what output? We are trying to find out what is the output Y. What is the output Y? Right. Okay. So what should be the final output Y? Y is the product of Q1 plus Q2 plus, that is equal to X1, X2 on negative edge. आपको नेगेटिव एज पे चेक करना है केवल. So let's come to the next negative edge, guys. The next negative edge, this is 1, but this part is 0, this fellow is 0. What is 1 into 0 is 0. So then second edge also the result should be 0. So let me write down Y is 0 here. Here also Y should be 0. Now next negative edge, this is 1, but X2 fellow is again 0. So what is the product of 1 and 0? It is still equal to the 0. The product of 1 and 0 is 0, right? Now coming to the final edge, this is 1 and here both are 1. Now look at this, here both the waveforms are at 1. So what is Y? Y is equal to 1 and 1, and the AND of 1 and 1 is equal to the 1. So for the first time output will raise high. For the first time the output will raise high at the last clock edge. So which of the waveform corresponds? It should be entirely 0, 0, 0. It will only rise high at the last negative edge, and that is the W3. That is what? That is the W3. That is the W3. So this is the correct waveform. This is the correct waveform, right? Look at this. Y is 0, Y is 0, Y is 0, and then Y becomes 1. W3 is the correct answer. What should be the correct answer, sir? The W3, option number C is the correct answer. So what do you understand from this question? Yeah, it's a important, and such questions, let me tell you, such questions are 2 marker category questions. 2 marker category questions, and if the concept of the flip-flop was clear, how it works, whether it is positive edge triggered, negative edge triggered, first of all you should be knowing that it is edge triggered, not level triggered. Definitely then the question is simple. It's conceptual. It's conceptual. Without the basic understanding of flip-flop, even the simple question can look difficult. Otherwise it is a very simple question, right? But can be expected for 2 marks level. Okay, let's move ahead to the next variety. Let's move ahead towards the next variety, guys. Okay, I hope that is clear to everyone. If there is any doubt, you can definitely let me know. The clock frequency applied to the digital circuit shown in the figure below is 1 kilohertz. Now let us talk in terms of waveform as well as timings, right? So there is a clock whose frequency is given to you, right? The clock and its frequency is given to you, that is 1 kilohertz, right? A clock and its corresponding frequency is given to you. That is given to you as the 1 kilohertz, right? If the initial state of the output Q of the flip-flop is 0, if the initial state of the output Q of the flip-flop is 0, then the frequency of the output waveform Q in kilohertz is. Then the frequency of the output waveform Q in kilohertz is how much? Right? So given the clock frequency, what is the frequency of the output Q? The question is asking, what should be the frequency of the output Q? Right. Now let us try to understand what actually comes to the T input, because it is a T flip-flop. Unless and until I know input, I cannot decide what is the output. I need the frequency of the output, but what is the output waveform? What is the output behavior? For that I need to learn what is the input to the T flip-flop, right? The input to the T flip-flop is equal to X. Now what is the value of X? Everybody, let us do the analysis of this diagram, right? Now this is the Q, yes, coming here, and the second is Q bar, right? Now look at the second gate, that is the XNOR gate. One of the input is Q, another one that is coming from here is Q bar. Here, that's the Q bar. Right. Now guys, everybody should know what should be the Q XOR Q bar. It is an XOR gate, and Q XOR Q bar should always be high, because Q and Q bar are always different, and whenever you provide the different input, the XOR gate should be equal to the high. The output of the XOR gate should be equal to the high. Now, what about this output, sir? This is Q XNOR Q bar. XNOR gate, also known as equivalence gate, which will only produce high output whenever both the inputs are same. But here both the inputs are different. Sir, here both the inputs are different. So the output produced will be 0. So it is very much clear what should be the value of X. One of the input is 1, another one is 0, and it is a NAND gate. 1 into 0 is 0, and the complement of 0 will eventually become 1. Yes, Jayapriya, correct. X value is equal to the 1. X value is equal to the 1. Right. Achha guys, let me keep you updated that. Oh my god, yes, so we have Ashutosh Saxena sir live. So after so many days, Ashutosh sir. So guys, let's have a warm welcome to God of Power Systems, all the electrical champions. Your favorite Ashutosh sir is live into the session. Let's have a warm welcome to it. And I was just about to say that, yes guys, these are some flip-flop based questions. Right. I am also planning very soon in a marathon form next to take up counter based question. Like flip-flop, we have taken discrete classes. Right. First we understood the latches, then flip-flops, then state diagrams, waveforms, everything we are trying to understand. Okay, but now I plan some direct counter sessions, but in the marathon form. Suppose 3 hours we come together and complete one type of questions of counter, another 3 hours. Like that I'm planning. That will be mostly on weekend, right? Okay, that will be mostly on weekend. So stay updated to the channel. Do not forget to subscribe our channel in case you haven't subscribed, because the next step, if you are comfortable with flip-flop, is definitely counter, where the good questions can be expected. Right. Thank you, Ashutosh sir. So guys, so yeah, stay updated to the channel. Probably in any of the weekend, maybe next weekend, or I'll see my availability, I will plan some marathon for the counter based questions, where we'll cover asynchronous, synchronous, all type of in the marathon form, in a long session form, all variety of questions in Go. So that can be a weekend. Okay, combinational. Okay, Navneet, we'll plan combinational also. But in flip-flop continuity, it's better to first complete the counters, and it is the very important part. Almost one question is expected mostly from the counter part only. Right, and asynchronous and synchronous, both the types of counter we can discuss. Chaliye ji, so t is always equal to the 1. What I can say here is t is equal to t is equal to what? The t is equal to the 1 always. And if the t is equal to the 1 always, q plus equal to q bar on every negative edge, because once again guys, you have to take a note that this is negative edge triggered device. This is the negative edge triggered. So q plus equal to q on negative edge, on every negative edge, So now let's see this diagram guys. Right. First, let me just draw a sample clock waveform in front of you. Just a rough waveform, okay? A freehand sketch quickly I'm drawing. Okay, and because once again the device is negative edge triggered, so I will mark the negative edges for you. I will just highlight all the negative edges in front of you. Okay, now it is very much clear in the question. They have mentioned in the question that the output of the flip-flop is initially 0. The output of the flip-flop, sir, is initially 0. The output of the flip-flop, sir, is initially 0, correct? Just a second. Just a second. Correct? Yeah, the output of the flip-flop is the initially 0. Now the output Q, this is the clock. Now I want to sketch the output Q, which is initially 0. But as I told you, output will toggle on every negative edge. So if initially it is 0, so at this edge, at this particular edge, it should toggle and becomes 1. And it becomes 1. Right. Now it will remain to be 1 until the next negative edge, and next negative edge it again toggles, it becomes 0. It remains 0 until the next negative edge, and at again this negative edge it is going to toggle, next negative edge again toggle, and etc. But this much is sufficient, because the question is asking the time period or the frequency actually of the output, and to decide the time period we should have the minimum time between the repetition. So I'll just highlight this portion. This is the first positive edge of the output waveform, and this is once again the positive edge. So this is the time period for repetition. I can say that this is the time period of the Q waveform. This is the time period of the Q waveform, the time between repetition, and the time of the Q waveform is equal to the how much, sir? The time of the Q waveform is equal to, now look at this guys, how much is this? This is the time between consecutive negative edge. That means it is the time period of the above waveform. It is the time period of the clock waveform. Right, this is one more time period of the clock waveform. So time period of the output waveform is equal to 2 times the clock time period. So we know that frequency is reciprocal of time period. Frequency is reciprocal of time period. So what is the frequency of Q? That is 1 upon time period of the Q. That is 1 upon 2t clock. And that is equal to 1 upon time period of the clock is frequency of the clock. So what is the frequency of Q? It is half the clock frequency. What is the clock frequency given in the question, sir? In the question, clock frequency given 1 kilohertz. Right, the clock frequency is 1 kilohertz. So this becomes 1 by 2 of 1k, and that is equal to 0.5 kilohertz. Or I can say that 500 hertz. They are asking the answer in terms of kilohertz. So it is the 0.5 kilohertz. That's it. It is a 0.5 kilohertz. Okay. Chalo. All cool. Yes guys, great. Let's move ahead to the next question. Yeah, this is once again a good question coming on screen, and that is a GATE 1 mark question. As a reference, I have taken a GATE 1 mark NAT type question, numerical answer type, as you are able to see. Consider the D latch shown in the figure, which is transparent when its clock input is high, right, and has zero propagation delay. Now the latch, they clearly even they have used the word latch, and we know what is the definition of latch, right, which is transparent when the clock input is high, level triggered. This is the level triggered case, right? And anyways, we know clock latches are level triggered. When we talk about edge triggered, it is basically the flip flop, right? So it is clearly mentioned, which is transparent, means which will accept the input, which is open to the input when the clock is 1. As long as the clock is 1, it will accept the input. So no longer it is edge triggered, it is a level triggered question now. Level triggered device question now. In the figure, the clock CLK1 has a 50% duty cycle, and clock CLK2 is 1/5 period delayed version of, so this is 1/5 period delayed version, right shifted version. Okay, what is the duty cycle at the output of the latch in percentage? What is the duty cycle of this output waveform, right? What is the duty cycle of this output waveform? So guys, if you are able to see, what is the actual clock? This is what is the actual clock. Okay, and the CLK1 is the input. This is actually the input. This is actually the D input, and this is the actual clock. Okay, this is the actual clock, right? CLK2 is the actual clock. The flip-flop will respond when the clock is open, when the clock is logic 1, because, sorry, not the flip-flop, latch will be open, the latch will be transparent when the clock is at level 1, because this question is based on level triggered device, not on edge triggered. The previous two questions were on edge triggered, right? So have a look at this. What is the output of D flip-flop? We just know that the output Q plus is equal to D. The output Q plus is equal to D, and D is equal to CLK1. What is the D? D is equal to the CLK1. The D is equal to the CLK1. Okay, G. The D is equal to the CLK1. Chalo. Okay. But the latch is transparent only when the clock means CLK2. So let me just highlight this, guys. You need to have a tracking of this. When the clock, the actual clock, which is CLK2, should be high. The actual clock, that is the CLK2, should be the high. Okay. Now, let's copy this. What is the initial output of the device? It may be mentioned, and even if it is not mentioned, by default it is reset. Any device will start from reset state. So initial output should be taken as the 0, sir. So let's take the output waveform here. everybody, which is initially taken to be 0, and it will remain to be 0. It will remain to be 0 unless and until this clock edge comes. Now, as soon as this clock edge comes, what you have to do? You have to just copy this part. You have to just copy this part, okay? Maybe I'll use a different color for this. You have to just copy this part. Because whenever, look, मैं लिख देता हूँ पूरा for your confusion, right? Whenever the CLK2 is equal to 1, the output will be equal to CLK1. So output you have to just copy the CLK1 part. Similarly, once again here, whenever the CLK2 is 1, the output will be equal to CLK1. So chalo, now let me trace this. Right, so the output becomes high. I have to just copy this portion. Right, I'll just copy this portion and it goes down. Right, now the clock is 0. Now clock is 0, so whatever is the state of the output will not change until this point. Will not change until this point, right? And again, we have to just copy this particular waveform. And etc. That's it. We have to decide what is the duty cycle of the output waveform, and we can even decide the time period, duty cycle, frequency, everything we are able to decide. Everything we are able to decide. Just have a look into this. Okay, this is known as first of all the time period. This is known as the time period of the output Q. This is known as the time period, the time between repetition. Acha, what is this time period? How much is this time period? Let me show you here. How much is this time period? So this is known as how much? This is known as 1 time the clock time period, right? But then how much is this period for duty cycle? For duty cycle, we have to take the on time period also. How much is the on time period? How much is this particular time? Can anyone decide? So see, this particular portion, I can say that if total time period is T clock, this is known as the T clock divided by 2, because the clock duty cycle is 50%. Clock duty cycle is 50%. So this is T clock divided by 2. 50% means 50% on, 50% off. So it is on for half the clock period, right? Now, how much is this duration, guys? How much is this duration? That is also mentioned, T clock by 5. That is also mentioned to you. Let me write down very clearly how much is this. This is the T clock divided by 5. So how much is this period? This is known as the T clock divided by 2, total T clock divided by 2 minus the T clock divided by 5, right? The T clock divided by 5. So 1 by 2 minus 1 by 5. 5 minus 2, 3. LCM will be 10. So this is known as the 3 T clock divided by 10. 1 by 2 minus 1 by 5 will be equal to the 3 by 10. So what should be the duty cycle? Let me complete here. What should be the duty cycle? Let me just complete the picture here. What should be the duty cycle? It is equal to on time period upon total time period multiplied by 100, because they are asking in percentage. What is the on time period? For how much time the waveform is on? On means logic level 1. It is on for 3 by 10 of T clock divided by total time period. Now, how much is the total time period? Let me write down this answer here. How much is this? This is the complete clock time period. Right, this is equal to the complete T clock. So T clock to T clock cancel. 3 by 10 of 100 is known as the 30%. 3 by 10 of 100 is known as the 30%. That's it. So in the percentage, what should be the final answer? In the percentage, sir, the final answer is 30. In the percentage, guys, the final answer is known as the 30. Okay. In the percentage form, the final answer is 3030. Right, all okay? Chalo. Moving ahead to the next question. So these are some good questions that we must practice from this topic. Now, this is again yet another good question. Yes, let's understand this question. Just a second. Yes, guys. Consider the following circuit involving a positive edge triggered D flip flop. Okay, so this is a positive edge triggered flip flop. It is no longer a level triggered device, it is the edge triggered device, right? And that is positive edge triggered. That is the positive edge triggered. So this time you are given a positive edge triggered. In the previous some of the questions we have seen the negative edge triggered also. We have seen the level triggered also, but this one is positive edge triggered. Consider the following timing diagram, right? Let AI represent the logic level on the line A. Let AI represent the logic level on the line A, right, in the ith clock period. Let A bar represent the complement of A bar या A dash या A prime. The correct output sequence on Y over the clock periods through 1 to 5. Okay, so clock periods have been mentioned to you, right? Over the clock periods through 1 to 5, what is the correct output sequence on Y? What is the correct output sequence on Y? This diagram is not available again, kya? Okay, so let me just solve it here only. Let me just solve it here, no problem. So what is the correct output sequence on Y? So first of all, how much is the Y? Y means the output of the D flip flop, that is Q plus, and Q plus is always equal to D. Now what is coming on the D? What is coming on the D? That you have to check. What is coming on the D? That you have to check. Now X waveform has been given to you, right? X may be 1, X may be 0. X may be 1, X may be 0. So sir, if the X is equal to 0, isko dekhna. If the X is equal to 0, let us just trace the signal here. X is 0, so this output is 0. X complement will be 1. So what is coming here? This is Q bar. Q bar into 1 will be Q bar. This is 0. This will be 0 plus Q bar, and that is equal to Q bar. 0 plus Q bar equal to the Q bar. So whenever X is equal to 0, whenever X is equal to 0, what is coming to the D input? What is coming to the D input? It is coming to be Q bar. Whenever X is equal to 1, then what is coming, sir? चलो ये भी check कर लेते हैं. Right. Whenever X is 1, so complement is 0. The second AND gate output is 0. Above you have A into 1, which is equal to A. And now this time this is A plus 0, that is equal to A. That is equal to A. So I can say that whenever X is equal to 1, D is equal to the A. D is equal to how much? D is equal to the A. Right. So that's it. Right. So let me just go and complete there. The output Y is Q plus. Q plus is equal to D. Q plus is equal to D. And furthermore, D is equal to how much? Furthermore, the D is equal to Q bar if X is 0. D is equal to A if X is equal to 1. If X is equal to 1. Right. So same thing I've just copied here. So let me remove it from here. It's a good question, guys, once again. It's a good question, guys, once again. Okay. Chalo, so let's look at the first positive edge. The device is positive edge triggered device, so I have to highlight the positive edges in front of you. I have to highlight the positive edges in front of you. Now here X is equal to 1. First positive edge gone, X is equal to the 1. The first positive edge gone, the X is equal to how much? X is equal to the 1. And whenever X is equal to 1, the output will be equal to A. Output will be how much? Output will be equal to the A. Now second positive edge again coming. Second positive edge again, consider the timing diagram. AI represent the logic level on the line and the ith clock period. Okay, so this is the 0th clock period, right? What was the previous state of the A? That is equal to the A0. So A0 will be taken here. A0 will be taken here. So what is the first output? Let me write down here. That should be A0. Now this is the first clock period. So value of A is A1. What is the value of X? Just the previous value is actually recorded. Always remember, right? Always remember. Right. Even in the, there is a concept of setup time and hold time also, but since you haven't learned that till now, but I'll just tell you, when you see the positive edge and this transition, just take the value before the edge. Just consider the value before the edge, right? So before the edge, what is the value of X? What is the value of X? Is equal to 1, and whenever X is equal to 1, output will be equal to A. Which A will be available here? This is the clock period number 1. So the A available here will be equal to the A1. So next output will be A1. Right. Now you see the next positive edge, and what is the value of X? X is 0. Whenever X is 0, the output will be complement of the previous output. Q plus equal to Q bar. What was the previous output? A bar, A1. So what should be the next output? what should be the next output? Okay, let me actually write down a little bit shifted. This is the output after first clock edge was A1, after second clock edge, first ke baad A0, second ke baad A1, now it is going to be A1 complement, right? Now next positive edge, what is the value of X? Is equal to 1. What is the value of X? Is equal to 1. X is equal to 1 A. Which A? The A during this cycle, that is known as the A3. That is known as A3. Next positive edge, what is the value of X? Just the previous value of X, again equal to 1. X is equal to 1. X is equal to 1. Output will be equal to A. What will be the A here? A4. That is the fourth clock cycle going on. So that is equal to the A4. That is equal to the A4. Now look at this. Now look at, no, B nahi, A is going to be the answer. A not A1, A1 bar A3, A4. A2 will be skipped here. A2 will be skipped here. Just A2 will be skipped here. Right. So just to eliminate all of your confusions, first positive edge, what is the value of X? 1. Second positive edge, what is the value of X? 1. Third positive edge, what is the value of X to be taken just before the positive edge is 0? Next positive edge, the value of X is clearly 1. Next positive edge, the value of X is equal to 1. And 4 times the X value is 1. So I take the value of A equal to, right. Now what is the value of A available here? If I want to write down the A values here, what will be the A values here? This will be A0. Here it will be A1. Here A2, A3, A4, A5, like that the values will be there. Okay, is that okay now? So the final correct answer is A0, A1, A1 bar, A3, A4. It's a good question again to be discussed, guys. Any confusion, do not hesitate in asking me the doubt. Do not absolutely hesitate me in asking the doubt. Okay, guys. So basically, once again, what do you understand from the question? These waveform based question, these timing based question just requires the pure understanding of the basic flip flops. Okay, understanding the next state of the flip flop, understanding what is positive edge triggered or negative edge triggered, understanding when the level triggered has to be used. So all the basics we have covered up, right? Level triggered, positive edge triggered, negative edge triggered, characteristic equation of all type of flip flops, whether it is D or JK or T or SR. And all those things can make this question simple if the concept is clear. Otherwise without concept, these questions can look like very difficult for you, but it's actually very simple if you have the basic concepts about the flip-flop clear, right? Okay guys, so yeah, that's it for few of the questions of waveforms from my side. And as I told you, now after the flip-flops, these were some questions based on the flip-flops. After the flip-flops, I'll try to bring you a session on counters, questions on counters, but in the marathon form rather than taking this discrete classes, because in this discrete classes I find that after 6-7 classes students also lose little bit of interest. So better we'll take a weekend, maybe Saturday or Sunday, any one of the day, and maybe 2-3 hours or even more than that, we will try to cover up the question of counters. I'll plan for it. Stay updated to the channel. Do not forget to subscribe the channel, okay, so that you don't miss any of those sessions. So guys, yeah, one more thing, that if yesterday any of you were waiting for my general session, that was the session on stress and anxiety in digital age, right? So there was some technical issue from the YouTube side, that is why the session could not occur. I actually went live, so I am live from my studio, but the video is not seen on the YouTube. There was some issue, and that even the team was not able to rectify because it was apart from YouTube. So unfortunately, that yesterday 10 PM general session, very important session, how to manage the stress in this digital world, could not I started, but it was not students were not able to view it maybe. Okay, but don't worry, I will replan it because that is a very important message, because there are some scientifically proven techniques to handle these cases. Okay, so I want to share it with that. It looks like a generic session, but there is some technical knowledge behind this, and we guys should, as engineers, should understand that, right? So I will definitely try to retake that session whenever some next available slot is there. Okay guys, so that's it from my side. Stay tuned to BYJU'S Exam Prep. Keep preparing, all the very best for GATE examination. The month of May has begun, and now your preparation should take one more step ahead, should take one more level ahead. Be more serious about the practice and the test series part now, right? Teja, what does JK mean? So already I have covered in my classes, so you can watch the previous class for the detailed concept. Right now I will just tell you the name. JK is Jack and Kilby. So actually there is some problem in the SR latch, an invalid state problem that was overcome by two persons known as Jack and Kilby, and hence the flip-flop was named over them, JK, Jack and Kilby latch. Okay Teja, So you can follow the previous classes, you will get that content also. Okay guys, bye bye. Thank you, all the very best. Keep preparing hard for the GATE 23 examination and do your very best.